Today we are looking at triangles, all the different kinds, and what we know about triangles. So first off, remember that a triangle is a polygon with three sides. And our symbol for a triangle is a triangle. And triangles can be classified, another word for classified is named, by their sides and by their angle measures. So we have a triangle ABC here. The sides of triangle ABC are segment AB, segment AC, and segment BC. The vertices of triangle ABC, remember that the vertices is just a fancy name for corners, are A, B, and C. First off, we're classifying our triangles by angle measures. Again, remember that classification is just another way to say name. Our first triangle, when we classify by angle measures, is an acute triangle. And it's acute because it has three acute angles. So all of the angles are acute. Remember that acute angles have to measure between 0 and 90 degrees. They don't equal 0 and they don't equal 90. Our next kind of triangle is an equiangular triangle. And the reason it is equiangular is because all of the angles are congruent. And the only way for all of these angles to be congruent is if each of those angles equals 60 degrees. So because each of these angles is 60 degrees, that means that this is also an acute triangle, because all of those angles are acute. They're all 60 degrees, and 60-degree angles are acute. Now notice that when I marked an angle, I marked inside and close to that angle measure. Angles talk about the corners, not the sides. Our next classification for triangle is a right triangle. And right triangles have one right angle. Remember that a right angle is 90 degrees. Your other two angles are going to be acute angles. Our last classification for triangles is an obtuse triangle. And obtuse triangles have one obtuse angle. Remember that obtuse angles have to measure greater than 90 degrees and less than 180 degrees. And again, there can only be one obtuse angle in an obtuse triangle. The other two angles have to be acute. Next up, we're classifying triangles by its angle measures. So by the angle measures means we're using one of these four classifications: acute, equiangular, right, or obtuse. And we're looking at triangle EHG first. So that's our largest triangle. So we have a 30-degree angle, a 60-degree angle, and then we want this whole corner. The whole corner is 90 degrees. So because it has one right angle, that means that this is a right triangle. Then we're looking at triangle EFH. Triangle EFH. So we know that these two angles are 30 degrees, and we don't know this angle. But notice that that angle makes a straight line with this other angle, the 60 degrees. So we can find the angle we're looking for inside of our triangle by subtracting that 60 degrees from 180. And that gets us 120 for angle EFH. And because that's 120 degrees, that means that triangle EFH is an obtuse triangle. And then our next one that we're classifying by angle measures is triangle FHG. So we have angle HFG and angle G are both 60 degrees. What's that mean about the last angle in this triangle? It is also 60 degrees. If you didn't know that, we had this whole angle equaling 90 and a part of that angle equaling 30. And 90 minus 30 is 60. All three of these angles are acute, so this is an acute triangle. But also, all three of these angles are 60 degrees. They're all congruent, which makes this also an equiangular triangle. Yes, you do need to put down both acute and equiangular when we have a problem like this. Next up, we are classifying triangles by their side lengths. Again, we're naming, but this time we're naming our triangles by the side lengths. This first triangle is a scalene triangle, and it's scalene because no sides are congruent. The next one is an isosceles triangle. And isosceles triangles have at least two sides congruent. Notice that at least part means it can have more than two sides congruent. Remember, those tick marks on the sides going through the side of the triangle tell us that these sides are congruent. And the last kind is an equilateral triangle. Equilateral triangles have three congruent sides. Now, this is also an isosceles triangle because it has at least two sides congruent. So scalene triangles have no sides congruent. Isosceles triangles have at least two sides congruent. And equilateral triangles have three congruent sides. First one, we're looking for triangle ABC, and we are classifying by the side lengths. Make sure you're reading directions. And we have that AB is 15, BC is 15. What's AC? It is also 15 because of that tick mark. So all three sides have the same measure. So that means that this is an equilateral triangle. and has at least two sides congruent, so this is also an isosceles triangle. Yes, both of those need to be put down anytime you have an equilateral triangle, because they both answer the question. The next one, we're looking at triangle ABD. So we have a triangle with a side length of 15 for AB, 18 for AD. And what's the length of AD? It's not 15, it's 20, because you're adding 15 and 20 together. So this is not isosceles. It is scaling because no sides are congruent. And the next one here, triangle EHF. So we have EH at 12, EF at 10. What is HF? It is also 10 because we have tick marks. So we have two sides that are congruent. So this is an isosceles triangle. Our next problem, we want to find the length of LK. So, on this one, we have what kind of triangle? Two sides are congruent, so this is isosceles, meaning that we can set those two sides that are congruent equal to each other. So 4x minus 1.3 equals x plus 3.2. That also means that JL is extra information. I don't need it because we are looking for LK. Now we're going to go ahead and solve. Subtract x from both sides. So we have 3x minus 1.3 equaling 3.2. And then we're going to add 1.3 to both sides. So 3x equals 4.5. And then we're going to divide by 3. And x equals 1.5. Now we're not finished because we just have x. We need to plug into LK. LK is x plus 3. 0.2. So 1.5 plus 3.2 is equal to 4.7. Our next one, we have an equilateral triangle. Remember, equilateral triangles, all of your sides are congruent, and we have information about all three of our sides. So it doesn't matter which of those three sides we choose. So we have 3y minus 4 equals 2y plus 3. Subtract 2y from both sides. So y minus 4 equals 3. Add 4 to both sides. And y equals 7. Next up, we have the triangle sum theorem that says that the sum of the angles in a triangle is 180 degrees. So we have angle A plus angle B plus angle C. It's going to add up to 180 degrees. Now, please remember this applies to angle measures. Angle measures are typically inside of your triangle in a corner with a degree sign by them. If they do not have a degree sign by them, do not use them as angle measures because they're not talking about angles. So our next problem, we want to figure out what angle NKM equals. NKM. So we already have two angles in that triangle, and we're looking for the third one. So we're going to take and add all three of those together. So x plus 48 plus 88 equals 180. Now we combine our like terms, and 48 plus 88 is 136. So x plus 136 equals 180. Then we subtract 136 from both sides. And we get 44 for angle NKM. And that's 44 degrees because we're measuring an angle. So I'm going to put that in our picture for that angle. Our next angle that we're looking for is angle JLK. JLK. So we're looking for the yellow angle. Now, there's only one angle in that triangle. We need to find the other angle. Notice that we have a line right here, and we have three angles making up that line. So we can find that angle by adding all three of those up and setting it equal to 180, because all three of these angles form that line, and lines are straight angles. So we have x plus 104 plus 44 equals 180. Add our like terms. Which gives us x plus 148 equals 180. Subtract 148 from both sides. And x equals 32. Now I'm going to plug that in, and we now have two angles in that triangle, and we're looking for that last angle. So again, we know all three of those angles would add up to 180, so we'd have x plus 70 plus 32 equals 180. Again, combine your like terms. So x plus 102 equals 180. Subtract 102 from both sides. And x equals 78 degrees. Next up, we've got some information about different triangles. The first one is a right triangle. And in a right triangle, your non-right angles are complementary, meaning your acute angles are complementary. Remember that a complementary means that they add to 90. So in this picture, angle D and angle E would add to 90 because this is a right triangle. The next one, anytime you have an equiangular triangle, each one of those angles is 60 degrees. So angle A is 60 degrees, angle B is 60 degrees, angle C is 60 degrees. And they all equal the same thing. Okay, next up, we are looking at interior versus exterior angles. Remember that interior is going to be inside of your triangle, exterior is outside of your triangle. So all of the angles inside of your triangle are interior, any angle outside of your triangle is exterior. That means that angle 4 is an exterior angle. Now, angles 1, 2, and 3 are interior, but angles 1 and 2 for this picture are a special kind of interior angle. They are remote interior angles for angle 4. Now, the reason why they are remote interior angles is that they don't touch angle 4. And we know something special about remote interior angles compared to the exterior angle. We know that that exterior angle, angle 4, equals the two remote interior angles added together. So angle 4 equals angle 1 plus angle 2. So now we're going to use that theorem. We know that 126 is our exterior angle, and we know that these two other angles are our remote interior angles. So we're going to set it up. Our exterior angle, 126, equals our two remote interior angles added together. So 126 equals 6x minus 1 plus 5x plus 17. Then we're going to combine our like terms. So 126 equals 12x plus 16. Now we're going to subtract 16 from both sides. And this shouldn't be a 12x, this should be an 11x, sorry. $110 equals 11x. Then we're going to divide by 11 on both sides, and x equals 10. Now that wasn't what we were looking for. We're looking for angle J. That means we need to substitute. And angle J was 5x plus 17. We need to substitute in for x. 5 times 10 plus 17. 5 times 10 is 50, plus 17 is 67 degrees. Next up, we are looking at the third angles theorem. So what the third angles theorem says is that when you have two triangles and two sets of congruent angles between them, in this picture we have angle L being congruent to angle R, and we have angle M congruent to angle S. When you have that happen, you have two triangles and two sets of congruent angles between them. You know that that last set of congruent angles is congruent. So you know that angle N is congruent to angle T. So in our last example, we know that angle B and angle E are congruent because they are both right angles. We know that angle A and angle D are congruent because they are marked with arc marks. That tells us that the last set of angles is also congruent, so we can set up 3y minus 72 equals y. Subtract 3y from both sides. That gives us negative 72 equaling negative 2y. Divide by negative 2, and y equals 36. But that wasn't what we were asked to find. We were asked to find the measure of angle C. And we know that angle C is y, which means that angle C is actually 36 degrees when we substitute.